Hello everyone and welcome to this lesson on the architecture overview of Angular. So Angular has several key building blocks, and these are the key building blocks: modules, components, templates, metadata, data binding, directive services, and dependency injection. Right, let's take a look at this one by one. Now, a lot of this is basically theoretical stuff, which probably won't make a lot of sense until you look at them during the lab sessions, but it's going to be good as well if I provide some kind of a general description of all these various components or various aspects of Angular before we start looking at them in more detail. So let's first look at metadata. Metadata is any kind of information associated with specific TypeScript classes. So your Angular program application is going to be written in TypeScript and is essentially going to be a TypeScript class. Okay, classes in TypeScript are similar to classes in other object-oriented languages like C# or Java or C++. So this metadata exists to guide Angular on how to process and utilize these TypeScript classes correctly. And the way that we do, or the way that we use metadata in TypeScript is through something called a decorator. So a decorator looks like this. It has the ampersand sign before it, and then it has a name. And there are several very important decorators that you're going to see a lot that are used on classes, on TypeScript classes. That is the add component and the add directive and the add ng module decorators, which are used to designate all these classes as either components, directives, or modules. So the way that TypeScript or the way that Angular distinguishes between these different kinds of classes as different kinds of aspects of its architecture is based on the use of decorators. And each decorator will also contain additional configuration options for that TypeScript class. Components are the building blocks of an Angular app, and they are basically TypeScript classes, so they will have this decorator add component on them, as we are going to see later in the practical labs. And each component will control the rendering of a matching template. So every component has a matching template. Okay, the template is basically your HTML. So your template is written in HTML, but it is enhanced with a special syntax that you don't find in normal HTML. Okay, so that syntax is called template syntax. It's a special syntax that is specific to Angular, right? So the templates are essentially just normal HTML enhanced with some special syntax called template syntax. And the component, which is a TypeScript class, together with its matching template, will define a basic UI unit called a view. Okay, so your Angular application will essentially consist of a collection of views, where every view is basically a single component and its matching template. Now, within a template, you are going to have something called data binding. So data binding is the way that you dynamically transfer data from the components, properties, or methods to the template DOM. So remember, I said that in a previous lesson, I said that HTML, when you load HTML into your browser, it gets converted into a DOM tree, right? If you don't recall this, please go back to the first lesson where I talked about web basics and the DOM tree. So your HTML, okay, when it's loaded in the browser, it gets converted into a DOM tree. So the DOM tree has a bunch of properties and methods that are exposed through an API, and the data binding allows the dynamic transfer of data from the components, properties, and methods to the templates DOM through its exposed API. And it also allows components to respond to events. So events might be user clicking on a element in the browser view, the user scrolling the mouse, the user typing in a text box. All these are events in the template DOM. So there are three main types of data binding. One is that goes one way from the component to a view target, which is called property binding. The other one is the other way around, one way from the view target to the component, which is called event binding, and two way between the view target and the component. Alright, so this is kind of how it looks like. This is your template, which is your standard HTML. This is your class. This is a TypeScript class, which is basically your component. And there's some metadata that is used to decorate this TypeScript class. And then property binding allows you to transfer values from the properties of your class into the template DOM. And event binding allows you to take data that is produced from events that happen inside the DOM and send it back to the matching component in TypeScript. Okay. So I mentioned just now that an Angular app basically contains a collection of views, and they are basically organized into a view hierarchy. So a template basically contains one or more child views, or what we call embedded views, and these views in turn can contain other child views, which creates a view hierarchy, which is an upside down tree that commences from what we call the root component or the root template. So it looks something like this. You have your root component, and then you have your root template. Okay, so this is the first component inside the Angular app, and then the root template, which is basically a HTML document, can contain references to other components and templates. So remember, a component and a template together is considered to be a single view. So you have the top level root view, and inside the template of the top level root view, you can have references to other child views as well, and then these other child views can have references to other child views, and so on. So you basically can have a very large tree that starts from this top level single root view, okay, and descends all the way down to multiple child views right at the bottom of the tree. So the entire view that you see in your browser is basically composed of a series of smaller views like this that are arranged in a view hierarchy. Next, we have directives, and directives render the template view by transforming the DOM of the template. Okay, so there are three kinds of directives. The most common one is a component, and we already saw the component. Every component is always matched with a template. Now, in addition to a component, we also have structural directives, and these alter the layout of the DOM by either adding, removing, or replacing elements in the DOM. And then we have the attribute directive, which alters the appearance or behavior of an existing element in the DOM. Okay, so the next part of Angular is called services. A service is basically a TypeScript class with a very well-defined purpose. Okay, so a lot of times you are going to want to have certain functionality that's going to be performed in your application many times. For example, logging. Okay, logging what the user does, what kind of requests are made by the user. You might have a need to communicate with a backend server, so you might need to send out HTTP requests to a backend server and get back response in the form of JSON. Okay, you might need to configure your application in some way. So all of these functionalities are implemented by a service. So a service is still a normal TypeScript class, but it has a very specific purpose, and these services are consumed or are used by other components that require their functionality. So the reason why we have services is because components, the TypeScript classes which constitute components, should only have functionality that focuses on the UI aspect. So remember that every view basically contains of the component and the template. So the template, of course, is what you see. The DOM of the template is what you actually see in the browser, but the component is going to control the interactivity of the DOM of the template. So basically the component is only really going to implement logic, the code that you write in your component, in the methods of your component. The code there really is only focused on managing the UI, managing how the DOM renders and so on. So for any other non-UI related functionality such as logging, data service, configuration and so on, that should be done by the services. Okay, so by having services, we are making sure that we have a clean separation between UI logic and business logic. Then we have something called dependency injection. Now, dependency injection is actually a software design pattern utilized in many frameworks or libraries. So it's not only specific to Angular. So if you work with frameworks like Spring, okay, if you ever work with Java Spring, the Java Spring Boot framework, it uses dependency injection a lot as well. Okay, so if you ever work with Spring Boot as the backend framework for application, you will probably be familiar with dependency injection. So dependency injection (DI) is not just something specific to Angular, but it's utilized in many other frameworks and libraries. And DI uses an injector to provide services. So services in Angular are achieved or provided through this mechanism called dependency injection, and injector will provide a new service instance from something called a provider. Okay, so here's an example of this. Of course, we're going to look at this in more detail in the lab sessions. So you have basically all these services which are TypeScript classes, and then Angular's DI framework will actually locate the correct service that's required, and you inject it into the component that requires the service at runtime. Okay, so dependency injection is a runtime mechanism when the component actually requires the service while it is executing. The DI framework of Angular will locate that service and inject it into the component. Then we have a module. A module is essentially just a grouping of logically related directives, components, and services. So modules in Angular are quite conceptually similar to modules that you have in C# or in JavaScript. If you have worked with modules before in other programming languages, then the concept of a module here is pretty much similar as well. So the idea of a module is to just group together these directives, components, and services that are related in some way, that perform some kind of related capability or that are used in a specific workflow. So your Angular app is organized into modules. There is always at least one module, which is the root module, and you can add in more modules if you want. So you can add in a feature module if you want, okay, but at the bare minimum you need to have one root module. And the app is launched by bootstrapping the root module, which we call app module, and the root module in turn will reference the root component. So the root component, as we saw, is right at the top of the view hierarchy. So when you bootstrap or when you start up your Angular app, the first thing that loads up is the root module, and then the root module will then load up the root component. The root component will then render the root template, and when the root template is rendered, it will render all its child views, and when its child views are rendered, the child views will render their own child views, and so on until the entire view hierarchy is rendered, and then you see the view in your browser, right? So that's how the Angular app will start up. So this is kind of an overview of the architecture. So the module, as you can see, is a collection of a variety of components, services, and other modules. Okay, then you have the template and the component. These are the core parts. These two things are the core of an Angular app. So you're going to have many components and many templates. Every component has a matching template, right? And then you have services. So there will be many services that can be created in the Angular app. So there might be a service to do logging, there might be a service to do backend calls to a web API, there might be a service to do configuration, and so on. So all these services are separate TypeScript classes, and the DI framework in Angular will locate the correct service and inject it into the component at runtime when the component needs that particular service. Okay, and we already saw the component will communicate with the template, with its matching template, through something called property binding. Property binding is where it will send values from its properties or from its methods to the properties in the DOM, and when events occur in the DOM, so events from the user interaction with the browser, the data from that user events are then transmitted to the component from the template through something called event binding. Alright, so let's look at the bootstrapping process. Bootstrapping is starting up the program. So you're going to have a particular program called main.ts. Main.ts will bootstrap the root module. So like I said, every single Angular app will contain at least one module. You can have more than one module, but at the bare minimum, you're going to have one root module. The name of the root module is called app module, and the app module will then have the name ng module, and the root module will start up the root component, which is called app component. So the root component itself will have a matching template, then you have the standard event binding and property binding, and of course we already saw this root template itself can have many child views, and those child views can have other child views as well. The root module called ng module can also import functionalities in other modules. It can also export its own services, components and directives for other modules to use. And then you of course have the providers. The providers are used together with the injectors as part of the dependency injection framework. And then you have all these bunch of services that are created. Okay, all these services here, these are all created and they are created by the developers, and they are registered with the dependency injection framework of Angular. And the injector, which is a part of the DI framework, will locate the correct services through what is called a provider, and then the correct service is then injected into the component at runtime when the component requires that service. Okay, so quite a lot of stuff we have covered here, so don't worry, we are going to cover all of these individually one by one in the different lab sessions to follow in this workshop.